today we're going to solve an word problem as an application of differential equation. We have here number 95. So when a capacitor of capacitance C is being charged through a resistance R by a battery which supplies a constant voltage E, the instantaneous charge Q on the capacitor satisfies the differential equation, this differential equation. So the thing is, we need to find Q as a function of time if the capacitor is initially uncharged, or this. So what we'll have to do is, first let us copy this. That would be R, dq over dt plus q over c is equal to E of t. So what we're going to do is, we have this R dq over dt. We have to transfer this. That will be E minus q over c. So this can be written as EC minus q over c. That will be R dq over dt. So we have to get rid of this R. We have to divide it over R. So we will have dq over dt is equal to EC minus q over RC. So we will do separables. So that will be dq is equal to EC minus q over RC. dt, that would be dq over this one, EC minus q is equal to dt over RC. So we will integrate both sides. We will have let u is equal to EC minus q. Our du would be negative dq. So this will be negative dq over u, and this will be 1 over RC dt, since RC here is treated as a constant. So this will be negative ln of u is equal to, this one is t over RC. So we will substitute RU. That will be EC minus q is equal to t over RC. So let's continue here. So this will be, let's write this one into this. That will be ln of EC minus q is equal to negative t over RC. We multiplied it by negative. So we will then raise it to E here, E. So this will be cancelled. We will have EC minus q is equal to E raised to negative t over RC. So we have to do this in terms of q. So that will be q is equal to EC minus, we forgot the plus c. So there is a plus c here, also plus c here. So when there's a plus c here, so when we have raised it to E, there's the c here. Okay, so we have here the c. So that would be EC minus c E raised to negative t over RC. Now in our condition, we have that at t is equal to 0, we have q is equal to 0. So with this, we have 0 is equal to EC minus c E raised to RT is 0. That will be 0 over RC. So this would mean that 0 is equal to EC minus this E raised to negative 0 over RC is equal to 1. So that would mean that this will, what we will have is, what is left is C. So this means that C is equal to EC. So we have here now our final answer. That will be Q is equal to EC. Then our C here is EC. That will be E raised to negative t over RC. So we can simplify this with factoring REC. That would be 1 minus e raised to negative t over RC. Now, this is our answer, our function of time in terms of Q. We have find Q as a function of time if the capacitor is initially uncharged. So this is now the final answer.